In the previous lessons, we learned how to use this solving strategy to convert between grams and mole, and we just have to multiply our given by one conversion factor, and that conversion factor is called molar mass. Now, in this lesson, we are going to use the same concept of conversion factors, but we are going to multiply more than one conversion factors because there isn't a single conversion factor that relate the two units. For example, in this case, use the given conversion factors below to convert between mass and the number of represented particles. And what are represented particles? Think of the term representative. It's representing the simplest form of matters, in this case, atoms, molecules, and ions. Well, here I have my conversion factor. 1 mole of calcium carbonate equal to 100.09 grams of calcium carbonate. Then we also have another conversion factor. 1 moles of calcium carbonate equal to 6.02 times 10 to the 23rd molecules of calcium carbonate. Now we have to remember this before, that E right there represents 10 to the power of something. So 6.02 E to the 23rd, it's actually equal to 6.02 times 10 to the 23rd. So let's solve this problem. How many molecules of calcium carbonate are in 35 grams of calcium carbonate? And if we look at this problem, we are trying to solve for molecules. So that is our unknown, where we are given 35.00 grams of calcium carbonate. And go back to this solving strategy. Well, we always start from our given, in this case is 35 grams of calcium carbonate. And we'll multiply the next conversion factor, but we don't know which one to use. Now, you have to look at this. We are trying to get rid of grams to get all the way to molecules. But if we look at this two conversion factor, right? This conversion factor does not even have grams at all, but it has the molecules. Well, the unit molecules doesn't happen until the very end. So we know that will be the last conversion factor that we have to multiply by. But the best bet that you are going to know which one you're going to use is you are going to look at this unit right here. Grams right there. Grams of calcium carbonate. So therefore, the next conversion factor, or the conversion factor that you multiply by, must have grams in it, or specifically grams of calcium carbonate, because you are going to cancel that out. Well, in this case, we have 1 mole of calcium carbonate equal to 100.09 grams of calcium carbonate. And then we know we're going to use that conversion factor. Well, if we look at this conversion factor, which one is going to be divided by? Well, we need to cancel the grams, so the grams are going to be on the bottom. So I'm going to put 100.09 grams of calcium carbonate. So this side is on the bottom. Well, if this side is on the bottom, the other side must be on top, because this is pretty much like a fraction. So we would have the 1 mole of calcium carbonate. Now we completely use all sides of this conversion factor. And notice how grams of calcium carbonate cancel out. Now we are going to multiply the next conversion factor because we haven't get our molecules yet. We are looking for molecules. In this case, we know right here, notice how the gram cancel out, giving us mole left, right? So we have to start with a conversion factor that has mole in it. Well, this 2 has mole, this one has mole as well. We use these conversion factors already, but here, look at this. This one has mole and molecules. So therefore, we now can complete our conversion factor. Of course, if we look at this, mole is going to be on the bottom because we need to cancel out that unit. And how many mole? Well, look at this. It's just 1 mole. So 1 mole is being divided. And if the 1 mole is on the bottom, therefore, this must be on top. And there you go. So let me show you how to do this on a Google Calculator. Again, multiply every single number on the top, divide every single number on the bottom. Well, what we have here is 35.00, right? Multiplied by 1. Okay. And then look at this number, it's on the bottom, so we divide it by 100.09. Okay, see how that works? Multiply everything on top, divide every single number on the bottom. And then the next one, see this is on top? So what are we going to do? We are going to multiply. And we know that E is your EXP right there. So 6.02 EXP 23. See how we multiply everything on top? And look at this one right here. It's on the bottom. So we divide it by 1. And look at our answer. You see right there, that E is supposed to be a capital E, 10 to the power something. So your answer is 2.105, and that 5 will make a 0 into 1. So we have 2.11 by rounding. And that go here. And that is all we have to do. Now let's go back and look at this. How would we write this on our paper? Well, a lot of you are drawing boxes. Remember, these are fraction. Okay, they are just fraction. So if we are to write this, this is how you write it. Just like fraction in your math class, we have 35.00 grams of calcium carbonate. And timed by this fraction. And of course, we have 1 mole of calcium carbonate divided by 100.09 grams of calcium carbonate. And we multiplied the next conversion factor. And the same thing, notice how I write this like fraction, right? So we have 6.02 times 10. Well, we're going to use the letter E for now. 23 molecules of calcium carbonate. And on the bottom, we have 1 mole of calcium carbonate. So this is what you are going to write mathematically. Well, look at this. Grams of calcium carbonate cancel each other. Moles of calcium carbonate cancel each other and give us ourselves molecules of calcium carbonate. And of course, if we write this in terms of using E, we have 2.11 times 10 to the 23rd molecules of calcium. Let's try another example. The same problem on the surface, but if you read it carefully, I just changed a few words. But the whole entire solution will be very different. Well, again, we are going to use the given conversion factors below to convert between mass and number of representative particles. And again, representative particles include atoms, molecules, and ions. And here are the two conversion factors. 1 mole of calcium carbonate equal to 100.09. Then we also have another conversion factor, 1 mole of calcium carbonate equal to 6.02 times 10 to the 23rd molecules of calcium carbonate. But in this problem, we are going to solve for how many grams of calcium carbonate. If there are 12.04 times 10 to the 23rd calcium carbonate molecules. So our given has changed as well as the values for the... So our given has changed from grams before to molecules, and we are now looking for grams, okay? So how would that work if we were to solve this problem? Again, always start from your given. Well, the given is 12.04 times 10 to the 23rd calcium carbonate. And this is our given. And we'll multiply by a conversion factor. And how do you know which one we multiply by? Well, we need to have the one that has molecules in it, because we need to cancel that out. Well, this one has molecules in it, and this one does not. So this second conversion factor has molecules in it, so we are going to use that one. Well, molecules are here, so we need to divide by molecules, which is this size right here, 6.02 times 10 to the 23rd, to completely cancel out the molecules. If the molecules are this size on the bottom, this 1 mole must be on top. So we have 1 mole of calcium carbonate on top. Now, molecule cancel each other out. The whole entire molecules of calcium carbonate completely gone. It becomes 1. Well, the next step is we'll multiply by another conversion factor, and we know for sure this conversion factor must have mole in it, specifically moles of calcium carbonate. Well, both of them has mole of calcium carbonate. Well, we used this one already. Now we have that one. Well, how do you know which one to use, or how you know for sure this must be the one? Well, first of all, it has mole in it, right? But most important, it has the unit grams that we are looking for. And that tells you right away, this is the last conversion factor that you are going to multiply by. Well, if this is mole, we are going to have this side on the bottom to cancel that mole. Now, if this side is on the bottom, the grams will be on top. And that's all we have to do. Now, let's do this in terms of using our Google calculator. So I told you before that you'll multiply every single number on top, divide every single number on the bottom. So we have 12.04. So what does the letter E represent? Well, E represents EXP. That's 10 to the power of something. In this case, 23. And you multiply by 1 because that's on top. And then you divide by this because it's on the bottom. So 6.02 EXP 23. And then this is on top. So what are we going to do? We multiply 100.09. And then the 1 mole is on the bottom, so we divide it. Boom. Now we have an answer. 200.18 grams. And that's all we have to do. And of course, let me go back and show you how would you write this on your paper. Again, you don't want to draw boxes. So what you're going to do is write this as fraction. So these are just fraction, okay? So we have our 12.04 E, and we're going to write that into 10^23 molecules. Remember, E is 10 to the power of something. And multiply by this fraction, we have 1 mole of calcium carbonate on top. And again, E is 10 to the 20. Again, E is times 10 to the power of something, in this case 23. And then we're done with that fraction. We multiply by the next fraction, and we have 100.09 grams of calcium carbonate on top, and 1 mole of calcium carbonate on the bottom. And then, look at this. Molecules of calcium carbonate cancel out. Moles of calcium carbonate cancel out. And we just have this times that, divided by that, times that, divided by that. And that turned out to be 200.18 grams of calcium carbonate. And that is how you show your work on your paper.